Hi everyone, my name is Sijun. The topic I'm presenting on today is flavor network analysis ingredients co-occurrence. On this project, I'm also working with Dr. Kalgotra and Dr. Trainer. Within 10 minutes, it's roughly a short period of time, so I'll try to walk through the research as much as I can with all of you. And my email is listed on the corner, on the right side hand corner. So if you want to email me with any of the questions or feedbacks, feel free to do so. First, I'll start with the introduction. The recent explosion of interest in the topic of flavor pairing has been driven by now discredited food pairing hypothesis, along with the emergence of the new field of computational gastronomies. So the idea of food flavor pairing is a perceptual pairing based on the combination of food and to see the similarity, contrast, harmony, emergence, or modulation. And data mining technologies such as ingredients co-occurrence network for modeling ingredients relationship is a somewhat recent endeavor in the research. And co-occurrence network has been used to capture the co-occurrence frequency of the ingredients to predict complementary and substitution ingredients combinations. The most common ingredients pairing used for the co-occurrence network are online recipe websites, nutrition information, and food chemical compounds. The use for restaurant menu data has not really been studied. So this research is aimed to graphically model modern flavor profiles and preferences and look into culinary regions in the US, the diversity of cuisines in the US, and predict key ingredients combination for novel culinary creations. Much of the recent interest from chemists and computational gastronomists in the topic of flavor perception focus on trying to explain or some good flavor pairings on the basis of chemical similarities between the compound flavor molecules. For example, if coffee and chocolate share a great amount of chemical compound, then they believe the food pairing hypothesis believe that they go well together. And IBM Chef Watson generates a pairing based on the molecule structure. However, this idea received a considerable amount of criticism, and it's really no longer being promoted as a genuine finding. The reason is after testing it empirically by researchers, some of these ideas are not necessarily work in the real world. So in this study, instead of looking at the molecular compounds or recipe data, we used a social network to create a visualized representation of the food relationship on menu data. It is a way to understand and collective interconnection of terms based on the paired and presents within a specific unit of text. If you are interested in the method itself, I would really highly encourage you to look up the method after this presentation. It is urgently really used to understand the social network, such as online communities, Facebook groups, but now the method itself has expanded to medical field and also the food field. In this graph, you can see the notes and the edges. The notes here in this study represents each of the unique ingredients, and the edge represents the relationship between these two unique individual ingredients. If these individual ingredients appear within one dish, then they have a commonality, so they form a relationship represented by edges. Menu item and some of the restaurant demographic information has been scribed from OpenTable.com. OpenTable, as some of you might not really know, it's a leading restaurant reservation management platform. With a selection of top 15 US food trending cities, we were able to get 4,624 restaurants and 166,866 unique dishes before the data cleaning. And for the data pre-processing process, we unified the case of the text, solved singular and plural forms, used powder stemming, and removed descriptive special characteristics, numbers, and some preparation words. Therefore, the entire edge is reduced to 92,954. On the top of that, in order to minimum the bias, the chain restaurants ascribed from the data set, we were able to keep one chain restaurant within one city and remove the rest of the chain restaurants. And from the table here, it's a table that represents the whole data set. This table reports the indicators of the data overview. Due to the time limit, I welcome you to ask questions, and also I prepared a slide at the end to show what each of these indicators means. But these indicators are pretty much the measure of clustering, density, and centrality. Based on the count connections, the following table shows the top 15 edges from the whole data set. So based on the table that we see here, you probably see a lot of tomato, onion, basil, and it appeared in multiple edges. And we were able to categorize the restaurants using the cuisine style. So we categorized all the restaurants from the identified labels on the open table into 6 categories: American, Asian, European, Latin American, Mediterranean, and fusion. Here, I will only demonstrate 2 of them, which is American cuisine profile and Asian cuisine profile. In this American cuisine profile, it is very interesting to see that the blue area is actually a subcluster of the sauce. Therefore, they all cluster together. The size of the notes actually represents the frequency. And in this bigger graph, you probably will see this big circle is actually a representation of the tomato, and tomato, lettuce, onion, bacon, avocado, zarala seems to appear more than the others. And here is the Asian profile. The Asian, it is very interesting to see that avocado is actually taking a really big portion of the ingredients, and it's very common to see in American Asian restaurants. Avocado is not really a typical ingredient found in Asian countries. However, in the US, avocado is very common and popular ingredients in sushi dishes. So it shows how foreign cuisine makes an effort to cater US populations. And it also verified that foreign cuisines have a tendency to make unfamiliar dishes with familiar ingredients in order to make the sale. And theoretically, this study is able to use a large-scale data and using an innovative, novel way to study menu. And the ingredients pairing from cuisine types perspective, which is a really unique point to bring into the research. Practically, it provides insights into contemporary American food and globalization in the culinary world. It really provides the tool for creating new food flavors. And of course, this study has its limitation. First would be the menu data. If you ever dine in a restaurant in the recent year or so, you might notice the menu actually listed important ingredients just to help you to make the selection. And menu data, although it has listed important ingredients in the dish, but it does not contain all of the ingredients. And another limitation will be the open table platform itself. It has limited restaurants because it is a paid platform. Therefore, restaurants needs to pay and to get listed on the website and to have the information such as menus to show on the website. I guess we still have a little bit of time, so I created this exercise just to help everyone understand each one of the measurements. And thank you. I guess that's all for my presentation.